All right, Math 1 people, we are going to be learning the last thing that we're going to be covering this year. And it's symmetric and skewed distribution. We've actually already talked about this, but today we're going to talk about how you look at it on histograms. But we looked at it last time on box plots, okay, the box and whisker plot. So I'm going to, just to remind everybody, I'm going to sketch a made-up box and whisker plot. Sometimes they're just called box plots, so if you hear box plots, it's this. Okay, the median's in the middle, and then we've got this long whisker below Q1, and then this second quarter between the median and Q1, that's long too, so long left side of the box, long left whisker, that's a left skew. Okay, means something is pulling the data down. There's something weird going down. Okay, these are histograms, and the way you do it with histograms, find your highest peak. Okay, the highest part of your data. Okay, so in this histogram, lots and lots of data has stacked on top of itself to make a really, really high area right there. And we're going to treat that kind of like the median. It may not be the median may be somewhere else, but we're going to treat it kind of like the median in a box plot. And what we're looking for is on which side is there a lot of just kind of extra data, smaller piles, smaller stacks. And that's going to give us left skew and right skew. So we've got the most in the middle there. And on box plots, these are called whiskers. In histograms, these are called tails, generally. So this is the right tail over there, and the right tail is longer. So you're looking at the tails as they come off of the tallest tower in a histogram. Which tail is longer? And then we have symmetric, which is normal distribution. Okay, so you can also hear it called that. And we're going to be looking at the tails on this, and they look about the same. In fact, for this one, they are exactly the same. They don't have to be exactly the same, they just have to be kind of close. But if you look up here for skewed right, that's 5 little towers after the big one, and skewed left, the left tail has 5 more little towers. Okay, so that's what you're looking for on histograms. You're looking for these tails that come off of the big tower. Okay, so for skewed left, most of the data actually ends up being on the right because most of the data is in that really tall tower, so the highest column. Okay, so we're looking back at our pictures. This highest column, there's a ton of data right there. So that's actually where most of the data is. And he's kind of on the right side. And then there's that tail going off to the left. And you name it after the tail. So find your highest column and then name it after the tail that comes off of it, whichever tail is longer. Okay, so for skewed right, most of the data is in that really tall column and the next highest column. So most of the data is actually on the left side. And then you've got more columns headed right. Okay, and then symmetric is down here. Most of the data is right smack dab in the center, and then the rest of the data is pretty symmetric, or, I'm going to underline this for you, almost symmetric. It doesn't have to be perfect. Okay, this one you kind of eyeball. This one's not an exact math. Okay, and that's how you find distribution on histograms. So find the highest tower, and then find which side goes the furthest going away from the tower, and that's the left or the right side. And moving on, we're going to practice finding distribution on a histogram. We're going to actually also practice drawing a histogram with a frequency table, so I'll show you how that works. Okay, the left side of the table, this is where you typically find x values, if you remember back to when we did function rules. And they still are X values. These are the bins that you stack the towers in. So this first one, if you sold between 1 and 8 tickets, apparently 5 people, that happened 5 different times. 5 different people sold between 1 and 8 tickets. Okay? And 9 different people sold between 9 and 16 tickets. And 16 different people sold between 17 and 24 tickets. Okay? So this X side is the bin. So it'll be the horizontal axis we'll use here in a second. And the right side gets to be the Y, or kind of the height of these towers or these columns that we're going to be building. Okay, so we are going to draw with a ruler here our handy histogram. So that first of all, we're going to label off the bins. I think I'm going to make this just a little bit longer here. There we go. I think that'll be good. We'll probably have enough room. And we will go up and down as well. Now, this looks a little weird because it's not a single X number. It's the numbers 1 through 8. But remember, histograms don't show exact data values. In fact, the table doesn't show exact data values. We know 5 people sold between 1 and 8 tickets, but we don't know if they all sold 7, if some of them sold 6, or if some of them sold 3, or we don't know what's going on there. Okay, so I made my first bin that goes from 1 through 8. I labeled the next guy 9, though, because he's the start of the next bin. So you label the next bin with the start of that bin. So this bin that starts with 25, that's what I'm going to label him. And the bin that starts with 33, I'm going to label him. And remember, 33 goes just to the right of that. Okay, and then here's 41, and then 49 starts our last bin. So I'm labeling them with the start of their bins, their bin size. And yeah, there's 57 if we had any, but apparently nobody sold more than 56 tickets. Okay, and you can kind of tell right now we're going to have our highest column is going to be 25 high on the Y. So what I'm going to do for the Y-axis is I'm going to label these guys by 2s so that we don't have a ridiculously high Y-axis. So that first little hash mark is 2, and this next guy is going to be 4, and the camera's getting in the way of the pen, so I'm going to move the paper. Okay, so we've got 2, 4, here's 6, here's 8, and I'm just going to label every other one because otherwise we have tons of numbers in. So 14, 16, 18, 20, 22, 24, and that guy's 26, and none of our Y's are any higher than 26. So we have a Y-axis that is now tall enough. Okay, so in the bin between 1 and 8, we need this guy to reach 5. So that's in between the 4 and the 6 tick mark on the Y-axis. Okay, there's our bin. There it is. And you can shade or color it in. I'm just going to leave it blank because this is just for distribution purposes. Okay, we're now going to go up to a height of 9, between 9 and 16. Remember, that's the Y-axis on that side of the table. So up here between 8 and 10, apparently I cut 11. That's okay. Close enough. Histograms are not really accurate sometimes. They're more close approximations. In fact, most of the time, most data I see is displayed in some kind of a histogram, but usually they will put a box plot alongside of it so you can see the quartiles and the median. Okay, here's our big one, all the way up to 25, in between, this is for our data values between 25 and 32, because remember 33 will go to the right. And then we've got 33 all the way up to 40, and this is, we're back down to 20, so we've passed the peak and now we're on our way back down. 41 to 48 has a height of 8. And then 49 starts the last one, and between 49 and 56, there were 7 people who sold that many tickets. So not a lot of people sold that many tickets. Okay, we have our histogram. We found our tallest column, and we're wondering what is the shape of the distribution. It can be left, right, or normal / symmetric. So I'm going to kind of just sketch in the tails here that are coming off of that tall column in the middle. And there's a tall column to the right, so you could say, well, maybe the two of them is where most of the data is, but then it gets small really fast, so it kind of evens out. So this is actually, even though it's not exactly the same, most of the data is in the middle, and the tails are about the same length, and they kind of even out in height. You get really tall and then too short on the right, and then kind of leveling down on the left. So this is actually symmetric. So it's not right or left skew. This one is symmetric. All right. Finally, we're going to look at something called the stem and leaf plot. It is yet another way of displaying data visually and organizing it visually. Just so you know, the stem is usually on the left side, and the leaves usually grow on the right side. So you got the leaves on the right and the stem on the left. That is not always the case, but it will be for this class. All right, so the way you work a stem and leaf plot, each data point, like if it's a double-digit number, the last digit gets to be the leaf on the right. The other digit gets to be part of the stem. Okay, and these kind of combine some of the features of dot plots and histograms. They visually, the stem and leaf plot visually show the distribution of data, so normal, skew left, skew right, all of those things. Okay, but you can also get the individual data points out of them, which you cannot do with a histogram. These aren't used a lot because most data sets have a lot more data and they just end up being hard to read. But small amounts of data, these things are still used. So here's how they work. So number on the left is number on the left. So here's 6, and the number on the right is the second digit, so that's 66. Here's a 31, but here's how it keeps working. You also have here a 32, okay, and a 34. There's 34, and then the next number, that's 39. So the stem numbers are like 10s, 20s, 30s, 40s, 50s, 60s. Okay, and the leaf numbers are the single digits. So you have 22, 23, 24, 27, 28. So everybody who lines up with the 2 stem, those are the 20s. So it kind of works like bins on histogram. You have 10s, 20s, here are the 30s, here are the 40s, there's 50s and 60s. And like histograms, also dot plots can do this too. You can tell right skew, left skew, and symmetric or normal distribution. The easiest way to do this is to turn it on its side. You want the small numbers on the left and counting to the right with the big numbers. And then you find the tallest set of numbers. And you're looking for the tail. And this one's only got one tail, and it's on the right side. That makes it right skew. So again, you name it after the tail. So find where the tail is that comes off of your tall column. All right, we've got this guy, and there's kind of 2 equal columns in the middle. And we're looking for the tails, and they come off one side and the other side, and they're pretty symmetric. It doesn't, I'm not seeing a huge difference here. So this ends up being symmetric. Last but not least, again, you're going to look for basically the biggest collection of numbers, which are in the 70s and 80s. Remember, you want small numbers on the left, counting to big numbers on the right. And you name it after which side the tail's on. So this one, the tail is on the left side. That makes this left skew. And that's about all there is to distribution on stem and leaf. And here's what it looks like if you tip it right side up again. Try and get all of these in the screen. So a left skew is going to be kind of bottom heavy, and a right skew is going to be kind of top heavy, small number heavy, and symmetric is going to have most of its numbers in the middle. So that's what it looks like right side up, but you can always tip it sideways, turn the paper counterclockwise, and look at it like a traditional histogram.